Okay, so let us start numerical methods and computer programming. So in the entire syllabus of mathematics optional, this is the most easiest topic, right? So this is the most easiest topic you can ever think of. So there are some standard rules which you will be able to identify those rules, and then actually you will be able to apply that, and then you can easily solve it. Yeah, so Vishal, so these parts are actually I will be covering as part of mechanics. Don't worry about it. Got it? Okay. So first let me list down the syllabus. So in the numerical methods, so solution of algebraic equations. Algebraic equations, variables by bisection, regular falsy, bisection, so regular falsy, Newton-Raphson methods, Newton-Raphson method, solution of system of linear equations by solution of system of linear equations by Gauss elimination, Gauss-Jordan, Gauss-Jordan, Gauss-Seidel iterative methods. So Newton's forward and backward interpolation, forward and backward interpolation, Lagrange's interpolation, and then numerical integration, in the trapezoidal rule, Simpson's rule, and Gauss quadrature formula. Numerical solutions of ordinary differential equations. ordinary differential equations, and in that actually Euler's and Runge-Kutta methods. So this is a part of the syllabus of this numerical methods, and computer programming is a separate topic. Got it? So I didn't check this question. So statics is already covered, right? So if you missed that part, then actually I'll be repeating this class at the end of the completion of the syllabus. So don't worry about it, Pankaj. Got it? Okay. So this is the numerical methods. Now actually the fundamental question is why do we need numerical methods at all? So in mathematics, why there is a topic called numerical methods at all? So there is a fundamental limitation in mathematics, says that we have a single, suppose if we have the equation, let us say ax square plus bx plus c equal to 0. And for that actually if I ask you to tell me the solution of this equation, immediately you say that x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So this is the solution of the quadratic equation ax square plus bx plus c equal to 0. Now, if I ask the same question again, can you try to solve ax cube plus bx square plus cx plus d equal to 0? What are the roots of this equation? Then actually, we cannot say the solutions for this directly. So you might go with different options by trial and error method. So in trial and error method, you may get or you may not get the solutions for this. And similarly, suppose if I say e power x square equal to 3x plus 4, then actually what will be the solution of this equation, or what are the roots of x which will satisfy this equation? Then actually there is no standard method that is available to solve this kind of equation. So in mathematics, so the limitation is you will be able to find out the solutions of the equation if it is a quadratic equation or a straightforward linear equation. Suppose if it is not a linear equation, suppose this is the case where it is not a linear equation, e power x square is equal to 3x plus 4, so it's no more a linear equation or a polynomial of order more than 2, then actually you will not be able to solve that kind of equations at all. So for that actually, as we were not able to find out the solutions with the help of analytical methods, so we tried approaching the computers. So computers actually, so they can do the iterative methods. For example, it can repeatedly do the same addition or the subtraction or the multiplication or whatever the method you adopted. By writing a simple program, you will be able to iterate as many number of times as you want, maybe 1 lakh times or 10 lakhs times or 1 crore times. It will keep on do the again and the same calculations it will try to do, and then try to find out the solutions for this kind of equations by iterative methods or the trial and error methods. So with the help of the computers, if you are trying to solve a problem, then actually we call that particular problem solution as the numerical method. So to use the computers to solve this kind of equations, what are the different types of methods that are available in mathematics? So here the condition is, because we don't know the analytical methods, we are going with the computers. So these are the iterative or the repeated methods, again and again try with the different values, or they will try to approach the solution or an approximate solution at least, so that you will be able to find out the roots for this kind of equations. So this is the fundamental problem of numerical methods. Got it? So for that actually, what are the different kinds of problems actually what we are trying to solve with the help of numerical methods is our syllabus, what we are going to discuss as part of UPSC. Now here actually there are different kinds of equations we are targeting. Solutions of algebraic equations. So this is an algebraic equation and this is an algebraic equation. This kind of equations actually, if you want to find out the value of x, then actually what are the different methods that are available? Those methods, those are the bisection method and the regular falsy method and Newton-Raphson method. These are the 3 different methods actually that we are going to discuss to solve this kind of equations. So in the regular falsy method, right? So this is also called as the false position method. So in that actually we are trying to approximate the root. Approximately you will be assuming one root and then you will try to find out the error. So in all the numerical methods actually what we are trying to do is, you will try to assume the initial solution randomly and then it will try to find out the error, and then you will try to approach a method which will reduce that error. So that method are different kinds of methods available. So this is one is the false position method and the bisection method. So bisection method is you will try to find out the two approximate roots and then actually try to find out the average of these two and then try to substitute whether you are going to get the same sign or not. If it is an opposite sign, then actually you will try to find out with the opposite sign one the average value and then try to approach a closer root than that. So there are different methods that are available to solve this kind of equations there. And then the next one is system of linear equations. That means if there are multiple sets of equations, maybe 2 equations or 3 equations or the 10 equations or the 100 equations or the 1000 equations. So if there is a system of linear equations, here the condition is the system of linear equations. That means all the equations are of the form ax plus by plus cz equal to k. And similarly, a1, b1, c1, a2x plus b2y plus c2z equal to k2. And similarly, a3x plus b3y plus c3z is equal to k3. Now, all these equations are the linear equations. A linear equation is nothing but a linear equation. Line meaning, so it will represent a kind of straight line if it is in 2 dimension. Now, this is a 3 dimension. Though it represents a plane, now whatever the equation of the order of whole power 1 for each and every variable in that equation, without any multiplication of any 2 different variables, that equation we call as a linear equation. Now here if you notice x power 1, y power 1 and z power 1. Nowhere actually we have x square or y square or y cube or anything like that. So nowhere we don't have that. And also no product of xy or yz or zx. So that kind of equation you can simply call as a linear equation. Or whatever may be the number of variables that are involved, suppose if it is multiplied with a constant and added with the constant multiplication of another variables, like that actually whatever may be the number of variables you can have it, that is also called as a linear equation. So this is a simple linear equation. Now a set of simple linear equations, if you try to solve it, you are going to find out the roots or the solutions of this particular set of equations which will satisfy all these equations. Now these things actually we will be discussing very clearly in linear algebra, where the solution can be there or it may not be there. So if it is there actually, then we can find out with the help of these numerical methods. But to find out whether it is there or not, we will be using the matrix methods for finding out the rank, and then actually based on the rank actually we will try to find out how many number of solutions that are there. Maybe it is a unique solution or maybe it may be infinite solutions. So that depends on the simultaneous equations that were given there, right? So all these things actually we are going to discuss as part of the system of linear equations solutions with the help of numerical methods. So in the numerical methods, to be specific, we are discussing certain methods, that is the Gauss elimination method and the Gauss-Jordan method and the Gauss-Seidel method. So Gauss elimination method is a direct method where you will be forming the system of equations as a matrix form, and then actually you will try to eliminate one by one, and then actually you will be forming a upper triangle matrix or a lower triangle matrix or a diagonal matrix, and then actually from there you will try to interpret the equations backwards, and then actually you will be finding out the unknown values there. So this is one method. In the Gauss-Jordan method also, you will be more or less following exactly the same method. A little bit of differences will be there. And in the last one is the Gauss-Seidel method, where we are trying to approach a numerical value which is a closer approximation to the solution, and then from there we will try to find out the error and then substitute back the error. So back propagation we call this. So we will back propagate the error and then actually try to find out a better solution there, and from there again you will find out the error and then try to repropagate back again and then try to find out the error again, and this process will keep on continuous till you get a better solution, or actually you will be fixing the error limit, and if the error is lesser than certain value you will be stopping, and there actually you are calling that as the solutions of that equation. So that kind of the iterative method we are going to discuss in case of Gauss-Seidel methods. Got it? And then in the Newton's forward and backward interpolation and the Lagrange's interpolation, there actually for an equation we will try to identify an extrapolated or the interpolated value for different values from the set of data whatever it was given. So from the data we are trying to predict a value for an unknown value of x there. So there are actually different methods that we are going to use in case of the backward interpolation and the forward interpolation and the Lagrange's interpolation there. And then the next one is the numerical integration. So in the numerical integration, see this. So generally actually the integration actually this is the form. So f of x into dx. So this is how actually we will try to find out the integration of any particular function provided it is integrable. Now here f of x into dx actually it will represent the area. Now this kind of integration with the help of numerical methods or with the help of the computers, you will be able to find out a numerical value for this particular integration after substitution of these limits. So this kind of analysis actually we are going to do it here. Here if you are able to analytically find out the solution for any random function given f of x dx, then actually that should be fine. Suppose if it is a function which is very complicated, then actually it is very tough to find out the integration of this with the analytical methods. There actually we will take the help of computers again, and then there are different methods that are available to find out the area under the curve of f of x, which we indirectly call that as the integration of the f of x with respect to dx, and that value you will be able to find out with the help of the three methods that are available. Those are the Simpson's rule and the trapezoidal rule and the Gaussian quadrature formula. So all these three methods actually we are going to use to find out the solutions for the definite integrals. So this numerical methods, if you notice carefully, it is available only for the definite integrals. For indefinite integrals we cannot do it, because actually in indefinite integrals nowhere actually you can use the values or the numbers there. So in the definite integrals only you have the limits and you have the function. There actually you will be able to find out the value of the function at any random location whatever you need. But if the limits are not given, then actually you will not be able to find out with the help of numerical methods to find out the integration of this particular formula, right? So that is the limitation. Now numerical solution of the ordinary differential equations. This is again the substitution methods only. So again we have Euler's and the Runge-Kutta methods. Those are the two different methods that we are going to learn. So here actually we are trying to find out the solutions for a differential equation, not an algebraic equation. So suppose if dy by dx is equal to kx. So this is just a differential equation. For this differential equation, so one method is you can straight away take this dx to this side and then I can try to integrate on either side. You will be able to find out the solution for this. But actually the same value with the initial conditions, if you are able to find out the solutions with the help of the numerical methods, so that you can do it here. So here this is a simple integration which you can do, and then actually you will be able to identify the solution for this. But what if it is a complex function like e power x square? Then actually you will not be able to find out the solutions for this kind of differential equations with the analytical methods, because you cannot integrate e power x square dx there. So for such kind of functions you can use the numerical methods to find out the solutions for this kind of differential equations. But here again so in all the numerical methods the limitation is you have to work with the numbers. Without the numbers you will not be able to solve that. Even here also, for the numerical methods to be applied here, you have to find out the initial conditions first. So you have to identify the initial conditions, and then you can make use of those initial conditions to identify the values of x and to identify the value of dy by dx, and then actually you will be using those values to satisfy this equation and then try to find out the error there, and then you will try to propagate that error back again and then try to identify a better approximation, and again this process it keeps on continuous. So these are the different methods actually what we are going to learn as part of this numerical methods. Got it? Understood? Any questions on this syllabus? Yeah, great. So now actually we are going to discuss this computer programming part. So that is far easier than this actually. So Higher Engineering Mathematics by B.S. Gravel is very good book for this particular topic. In the computer programming, so binary system, arithmetic and logical operations, arithmetic and logical operations, octal and hexadecimal systems, octal and hexadecimal system, conversion to and from decimal system, to and from decimal system, algebra of binary numbers, elements of computer systems, and concept of memory. Concept of memory, basic logic gates and truth tables, logic gates and truth tables, Boolean algebra and normal forms, representation of unsigned integers, signed integers, unsigned integers and the signed integers, reals and double precision reals, and long integers, algorithms and flowcharts, for solving numerical methods. So this is the complete syllabus of this computer programming. Now if you notice, so to summarize this entire topic, right, So this is just to deal with the binary number system, nothing more than that. So here actually the main application of this binary system is with the help of computers you will be able to solve the problems, and then the basics of this computers is built on the base of this binary number system. Hence actually we should be aware of what we are going to deal with in case of computers, especially at the hardware level. So at the hardware level, so we will be working only with the binary number system there. So the processor is designed with the help of binary number system. Now actually, what are the different uses of this binary number system and how to convert from one form to the another form, like binary to octal and octal to hexadecimal and decimal to hexadecimal. Like this actually, any number of combinations actually you can take it, and then actually you have to identify. So in real world actually we are going to deal with the real number system or the decimal number system, and here actually the computer can deal with only the binary number system. To understand better actually we should be aware of how to convert from binary to decimal and decimal to binary, and then for a better design purpose at the hardware level, so the binary number system has to be dealt with octal number system and the hexadecimal number system to simplify the project or to simplify the processor what we are going to design. So there actually these number systems of octal number system and the hexadecimal number systems are very important there. So that also we have to be aware how to convert this binary number system to octal and octal to hexadecimal, like that. So all these things actually we are going to deal in this particular topic. So here actually binary number system and arithmetics and logical operations of binary number system. So here actually there is a kind of decision making which we call as the logical operations. So in binary number system there are only two different symbols actually what we are going to use it, either 0 or 1. Now with this 0 and 1, the algebra whatever we define for normal decimal number system has to be redefined for this particular binary number system. So there actually plus means different and minus means different than what we are going to learn as part of algebra. So all those things actually we are going to deal in a detailed manner at this stage. Now here octal and hexadecimal number system. So this is also called as the base 8 and base 16 number system, and conversion to and from decimal number system to these number systems, maybe decimal number system to binary and decimal to hexadecimal and decimal to octal or vice versa. So basic knowledge is compulsory for this particular. What kind of basic knowledge? You don't need any kind of basic knowledge for this. I will start from the scratch. So I will start from the definition of the number, and then I will try to cover each and every aspect of this. So you don't need any prior knowledge for this. Got it? This is the most easiest topic actually. So algebra of binary number systems, and then elements of computer system. So here actually the basics of all the binary number system what we are going to learn is to apply or to make use of this binary number system for the computers. So where we are using this, so that has to be dealt. So where we are using is in a computer system, especially to design the memory and the processor. So these are the two places actually where this binary number system is getting used as part of a computer or a cell phone or a laptop. Got it? So there actually where we are using all those kind of concepts actually we have to be learning at this location, right? And then basic logic gates. So logic gates actually are part of decision making blocks, or the addition or the arithmetic operations also. These logic gates actually we are going to use it. So logic gates are nothing but the building blocks of any bigger system. So building blocks of any processor. So these logic gates actually, what is meant by a logic gate, and then how we are going to design a logic gate, and how you can make use of these logic gates to design a processor. All such kind of things actually has to be known at this particular stage, right? So here actually logic gate is nothing but you started with 0 and 1, and then if you wanted to identify an operation like addition of 0 and 1 has to result into a 1. Now for that actually you have to make use of these two numbers, and then you have to identify a mechanical system where it can result into the sum of these two. That mechanical system has to be dealt with the help of metals, and then there actually what we are going to use or actually how we are going to design has to be pictorially to be represented here, and that representation is called as a logic gate there. So these logic gates actually how we are using it, or actually how we are defining a logic gate, all those things actually we are going to learn as part of this logic gates and the truth tables there. So truth tables are nothing but the logic gate behavior. So that behavior is represented mathematically there for the analysis purpose. So those are called the truth tables. So and then Boolean algebra. So this is a separate algebra. So in Boolean algebra, like actually in our decimal algebra, 1 plus 1 is equal to 2. But in Boolean algebra, 1 plus 1 is equal to 1. So these are actually these operations or this algebra definitions of addition, multiplication, subtraction and all those things are redefined as part of this Boolean algebra to deal with the binary number system for the application of the logic gates. So there actually we are going to redefine this algebra, which is nothing but plus, minus and into. So these are the three different operations actually we are going to redefine to design a mechanical system with the help of a processor. So there actually we are going to use this Boolean algebra concepts there. Got it? And then normal forms also is part of the new Boolean algebra itself. And then representation of unsigned and the signed integers and reals and doubles, double precision reals and long. So long is nothing but long integer. Now actually whatever we are convenient with are only the real numbers and the decimal number systems. So these are the two number systems actually we are very much familiar and we are convenient to write and read and to understand. But computer can understand only zeros and ones. Now actually the problem statement is how you are going to represent these values of the real numbers or the decimal number system or any integer or a signed integer. Signed integer means plus 2 or minus 2. So this is a signed integer. So how you are going to use this plus 2 and minus 2 to represent, how you are going to use the binary number system to represent these negative values and the positive values. So that actually we are going to discuss it here. Even the long integers. Long integer means which is a bigger integer value. Now actually this integer actually when we define, you are going to define the length of the byte. So this length of the byte actually is sufficient to represent one integer. Now actually suppose if you wanted to represent a very big number, then actually one byte is not sufficient there. So we are going to make use of 4 bytes or the 8 bytes like that actually we are going to make use to represent very bigger numbers. So all those things actually why we are dealing. So here at this location we are going to deal with that. Got it? So and then algorithms and flowcharts. Algorithms are nothing but the step-by-step procedure to solve a particular problem. So this is just a step-by-step procedure. If you are writing in a step-by-step manner, and that's what is called as algorithm. Finally, the target is to solve a problem there. So exactly in the similar manner, it is far easier to understand provided if it is represented the same steps in a pictorial manner. So that way of representing the solution in a pictorial manner is called a flowchart. So all those things actually for different kinds of problems actually we can try to understand how we are representing the algorithms and the flowcharts for solving different kinds of numerical methods. For example, maybe regular falsy method or a bisection method. What are the different steps you are using? If you write it in a step-by-step manner, then we call that as an algorithm. And if you put it in a diagrammatic manner, then the same steps we call as a flowchart. So these are the things actually to summarize what we are going to discuss as part of this computer programming part. Got it? Understood? Any questions on this? So, yeah, okay. So the book is like actually there is no specific book actually what you can so maybe what you can make use to understand all these concepts, but actually based on the engineering background, right? So that is Boolean algebra. Actually, there is a separate book. So Kohavi by author. So this is the book actually, but actually I don't think you need to purchase this book and then actually study all those things. So whatever the classes I teach, that is sufficient enough, that knowledge is sufficient enough, and whatever the material I provided, right, so that is also sufficient enough for us. So you don't need to buy and read all these things because actually this is a little tougher. So it gives a lot of other information which is not useful for you. So that's why avoid purchasing this book. You try to depend on the material what I have provided and then try to follow the classes whatever I explained. That is sufficient enough, I think. So this is not a bigger topic, or actually this is not a tough topic. So this is just a common, with common sense you will be able to understand each and every aspect in this. Got it? Any questions on this? Okay. So this is the syllabus. Okay. So now actually first let us understand what is a number system. So we'll start with the computer programming first. We'll finish this and then come back to the numerical methods. So first actually we'll start with the computer programming. So a number system. So a number system is nothing but a set of symbols used to represent numbers. So our familiar number system is decimal number system. So a decimal number system meaning deci means 10. So we are going to make use of 10 different symbols to represent a number. 10 symbols are used. To represent any number. So this is what is called the decimal number system. Those 10 symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now here actually these are the 10 different symbols actually what we are going to make use to represent any number. So hence it is called as the decimal number system. Now, so I started learning this. This is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now here actually I have used all the symbols now. So I wanted to write the next number. After 9 actually I wanted to count the next number. For that actually, because I have used all the symbols there, then I have to identify a different set of symbols, or actually I have to make use of these symbols again, which is unique to represent the number. So that unique number you can identify as, this is actually 0 and 1. Now here actually in the prior side, so as there is nothing, you can keep this as 0. That means I started with a number 0, 0, 0, 1, 0, 2, 0, 3, 0, 4 like that. Now I have used the first symbol here. So as I have counted all the symbols here, I can keep the next symbol whatever is coming after 0, and then I can again repeat the same number so that I can get a unique number there. So that is 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. So now actually again, after incrementing to the next number, here also I have used all the symbols again. Then actually if I wanted to go for the next number, then I have to use the next symbol there. So there it is 2, 0. So like this actually, I can write till 2, 9. So this way I can keep on write all the symbols till 99. 90 to 99. Then after that, in this particular position, I have used all the symbols available there. So 0 to 9 I have used already. So the last number what I have got here, it is 99. Now actually if I wanted to increment to again, then actually 9 becomes 0, because actually after 9 symbols I have used, I start using the same symbols again and again. So that means because I have used all the symbols, then I have to start with the first symbol again. So then actually it is going to be 0. Now here also I have used all the symbols again. Then if I wanted to go for the next symbol, as I have used all the symbols, I can go for the next symbol as the first symbol again, which is 0. Now as this 0, 0 is already there, then actually if I wanted to unify this, then actually I can make use of the next symbol here because this can be treated as 099. So 9 after again it comes back to 0, and this 9 after again it comes back to 0, and this 0 after it will come with 1. So hence we got 100 as the unique number to represent, right? So again actually you start incrementing these numbers. So 10 you keep it as it is, and then 100, 101, 102. Like this actually, this 10 is kept constant, and then you will be incrementing till 9, 109. Afterwards, this procedure continues. So this continues until 999. Again, as I have used all the symbols for the first one, then I have to go for the next symbol, so which is available only as 0, and then here also 0, and here also 0, and then as you need to increment the next one, so that is coming out to be 1. Like this, you will be able to write any number with the help of these 10 symbols that are available there. So this number system, which is very popular for us, so this is called as the decimal number system. With this, you will be able to write any unique number. Got it? Now, the same methodology, whatever you are using it here, this method, it will be used for any kind of number system. The same method, same way. So whether it is a binary number system or an octal number system or an hexadecimal number system or any kind of number system, we have to follow the same procedure to write the numbers. Got it? Now here, suppose, let us say I use octal number system, let us say. So in octal number system, the symbols actually I can make use those symbols. So if it is an octal number system, I can make use 0, 1, 2, 3, 4, 5, 6, 7. Now these are total 8 symbols. Now these 8 symbols I can make use to represent any number. So here 0, 1, 2, 3, 4, 5, 6 and 7. So I have used all the symbols now. So as I have used all the symbols, then actually I have only one option, that is I have to go for the next symbol here, that is 1, and then this one, as the cycle is completed, I can again start back with the same cycle, 1, 0. So 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 and 1, 7. Now again I have used all the symbols at this location, and here actually I have used only 0 and 1. So I can go for the next symbol, then 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6 and 2, 7. So like this actually I can keep on write the numbers, and then suppose if I get 7, 7. So I have used all the symbols even at the next place also. Then if I wanted to increment to the next cycle, then this 7 has to become 0, and this 7 also has to become 0, and then actually it comes back to 1, 0, 0. After 7, 7, it will be 1, 0, 0. Got it? So don't confuse this as the 77. So this is just 7, 7. So this is how actually an octal number system can be written. Now the same method actually you can make use even to write the binary number system, where you have got only 2 different symbols. Similarly, you can write the hexadecimal number system, where you have got the flexibility of 16 different symbols you can make use to write any number. But to be specific, if you notice, whatever may be the number of system, every possible number actually you can identify with a unique number. So whether it is an octal number system or a decimal number system or a binary number system, you can identify infinite numbers. Whatever may be the number of system, you can make use. Got it? You can identify infinite number system, infinite numbers. Every number is uniquely represented in any number system here. But the equivalence of number system is different. That means here actually 77 is not equal to 77 of decimal number system, because here we have used the 10 symbols and here we have used the 7 symbols or 8 symbols. Got it? So this 77 and this 77 are not equal. So 77 base 10 is not equal to 77 base 8. Got it? So here the meaning is different and here the meaning is different. This 77, what we feel as the 77, but this 77 is not what we feel as the 77. Got it? So here the equivalency between these two needs to be calculated. That kind of conversions actually we have to identify the methods how we can convert a base 1077 to a base 8 number, or base 877 to a base 10 number. Similarly, a binary to hexadecimal and hexadecimal to decimal or octal, any number system actually you can convert. But in whatever may be the number of system it is, here actually the same methodology we are going to adapt to write any number. Got it? So if it is a binary number system, then 0 and 2 are the only two symbols. So these are the only two symbols you can make use to represent any number. Here 0 and 1. Now actually I have used all the numbers now. As I have used all the symbols here, so option is I can increment the next symbol here, and then actually I can start with the cycle again. So 0 0 and 0 1, and then this 1 becomes 0, and then as I have used 0 here, I started using 1. Now here again 1, as I have used 0 here, I can increment to the next symbol 1. Again I have got 0 1 I have used already. Now I can go with 0 because I have used, right? So then here I can increment to the next symbol, but here also I have used 0 and I have used 1 also. So only option is I have to increment to the next symbol here, and then I can keep 0 here. So this is 1 0 0. So this is the next number, and then again you can start incrementing from here. So 0 becomes 1, and then 1 0 1, and then actually again I have used the two symbols here. Then I have to increment, that is 1 1 0 and 1 1 1, and then 1 0 0 0. So like this actually this number system has to be used. Yeah, 0 and 0 0 are one and the same in whatever may be the number system it is. Got it? I hope you understood this concept. This is the basics of any number system. So this you can make use to write any numbers. Understood? Got it? So here actually we have to identify this base. Now in any number system, if you notice, let us say if I write 123. So here actually 123 meaning for us it is 1 into 10 square, 2 into 10 plus 3 into 10 power 0. So this is the meaning of it. That means here this can be written as 100 plus 20 plus 3. So this is 123 for us. Now here what we have done here it is, see this, here actually in the units place I have used the unique symbol directly there. In the tens place I have used the second symbol once, so only after I use 0 and 1, then I started with 2. That means by the time it comes here I have used actually this symbol 2 times, right? So here actually 2 meaning, so this can be treated as 2 times of 10. And here 1 I mean I have used actually, so for one cycle here this is 1 increment. Now for one complete cycle of this actually it has to be 100 increment. That means this has to be 10 square times of increment I have done. So here 10 square into 1, 2 into 10 plus 3 into 10 power 0. So this is what is the base for us. So this base actually I have made use to identify this 123 as 100 plus 20 plus 3. So whatever may be the number, if I give it, suppose 346, then this 346 can be written as 3 into 10 square plus 4 into 10 power 1 plus 6 into 10 power 0. Now here this is 10 power 0, this is 10 power 1, and this is 10 square. So for the base whatever we have used, or the number of symbols whatever we have used, here the first number needs to be multiplied with the power 0 of the base, and the second number has to be multiplied with power 1 of the base and power 2 of the base. Like this, actually you can keep on write whatever may be the number you have it, whatever may be the number of symbols you have in that particular number. For this number, for each and every digit, this is how actually you can identify the value of the number with the help of the base like this. Got it? So this way, exactly in the similar manner, so depending upon the number system, whatever we are going to use it, suppose if I say 100 in base 2 number system, which is the binary number system, then this can be treated as this 0 into 2 power 0 plus the second 0 into 2 power 1 plus this first number into 2 power 2. So this is 4 plus 0 plus 0. So this is equal to 4. So like this, actually any number system, if you know the base, then you will be able to convert into the decimal number system in this particular manner. Because in decimal number system, we know whatever the number of symbols actually what we are going to use for any kind of number system. Got it? In octal number system, we are using 8 symbols. Now it is convenient for us to express in the decimal number system. So here actually, suppose if I say 77 as the octal number system, the decimal equivalent of this number is, this is 7 into 10 power 7 into 8 power 0 plus 7 into 8 power 1. So this is the decimal equivalent there. So this is 7 into 8 plus 7. So this is 56 plus 7. So this is 63. So this is the base 10. Got it? How we are converting to any number system to decimal number system. This is how actually you can convert. Whatever may be the base it is, exactly the same procedure you can adapt to convert into the number system where you are very familiar with, which we call as the decimal number system. Got it? Understood how to convert a number system? So this is how you can convert it. Suppose actually if you want to convert 70 or 78 base 10 to base 8 number system, then actually how to solve this? So you want to convert 78 to base 8 number system. In the base 8 number system, you will not find this 8 symbol because actually 7 is the last symbol here. Now here to convert this, right, so the standard method is from decimal number system to any kind of base it is. So the standard method is to divide with the base. To divide with this base. Now 7 you have to divide 78 by 8. So 78 by 8 is so 9 times. Now the remainder is, so this is remainder 6. Got it? Now here again you divide with 8 and here this goes once and the remainder is 1. Again if you divide with 8, then actually it goes 0 times and it leaves a remainder of 1. Now you write the symbols from bottom to top. So 116 base 8 is the value of 78 in base 10. Got it? 116 base 8 is the value of 78 base 10. Now actually if you want to verify it, you can cross check it. 116 base 8 can be written as 6 into 8 power 0 plus 8 power 1 into 1 plus 8 square into 1. Now here this is 64 and this is 8 plus 6. So this is 78. Got it? I hope you understood this concept, how we are converting any number system to decimal and decimal to any number system, the same methodology. Here actually, if you understand one method, so that is applicable for all kinds of number systems. So you have now actually you got to know that. So how to convert from one number system to another number system, that is decimal to any number system or any number system to decimal. So this you have understood, right? And then actually you understood how to write the numbers. If it is a decimal number system, how you are writing it. The same methodology we are making use to write any number system, though it is whether it may be a octal number system or it may be a binary number system or it may be a hexadecimal number system. You can make use of the same methodology to write the numbers. Now here actually hexadecimal number system where you can make use 16 symbols, but actually in decimal number system we have got only 10 symbols, but remaining symbols, right? So you need to identify 6 more symbols. So those 6 symbols actually we can make use of A, B, C, D. So like that actually in hexadecimal number system the symbols what we are going to use are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E and F. So these are the symbols actually what you can make use to write a hexadecimal number, because we know the symbols for the decimal number system which are only 10, but you need 16 symbols to write into the hexadecimal number system. Got it? So we are mainly dealing with binary, octal and hexadecimal. So these are the 3 different number systems we are rigorously dealing with. Why? Because in computers actually for designing purpose it is easy to write the numbers in hexadecimal, and then sometimes actually for the old systems actually we are using octal number systems for the design purpose, but computer can understand only binary number system. But the conversion from binary to octal or binary to hexadecimal or octal to binary or hexadecimal to binary, it is straightforward and easy. It is as simple as just putting a comma to convert from one number system to another system. So that's why these are the 3 different symbol systems actually what we are using in case of computers. But for human understanding purpose, decimal is far easier to understand because we got used to that. But computer can understand this. So you need to be converting all these things into decimal and decimal to that one. Got it? So this is the essence of that syllabus. I hope you understood fairly good, I think. Any questions on this? Okay. So with this actually I would like to stop the class for today. So in the tomorrow's class actually I will continue this discussion.